Hello friends, today I am here with a new topic, testing of hypothesis, which is an integral part of inferential statistics. We already have done 2 videos related to theory of estimation, and now we are starting with a new topic which is called testing of hypothesis. Again, as usual, I am here with a new question that we will going to solve here with a little bit concept that I will also going to deliver with this solution. So let us first try to understand the question. In a sample of 400 parts manufactured by a factory, the number of defective parts was found to be 30. So, from a factory, we are collecting 400 parts as a sample, and from there, it is found that 30 of that 400 parts are defective. The company, however, claimed that only 5% of their product is defective. Now the question is the claim tenable? That means we have to find out statistically that whether the company is true or company is false. Okay, so this is the question, and let us see how to solve the answer for this. Now why this is testing of hypothesis? Why this is a question under testing of hypothesis? First let us understand what is testing of hypothesis in 1 or 2 words. Hypothesis is nothing but an assumption, okay? An assumption about the population parameter. We know that in statistics, the most important part is the population, because whenever we want to draw any inference, we have to draw the inference on the population. But in most of the cases, the population is not available to us. Maybe the entire population is not accessible. Maybe it will take too much of time, or it is very much expensive to reach each and every unit of the population. So in statistics, what we do, we used to collect the sample from the population, and we have to make sure that the sample is a true representative of the population. So in general, we have to collect it by randomly. So random collection of the sample, so that the sample units collected are independent of each other, can assure us that we are collecting representative part of the population. Now, while we are collecting the sample, obviously we will be getting the sample statistic. We can get the sample proportion, we can get the sample mean, we can get the sample variance, right? But these are the values which are available to us. These are not fixed though, because we can have innumerable sample from a single population. But with the sample that we are collected, with the sample that we are actually collecting from the population, we have to estimate the population parameter, and we have to make assumption about the population parameter. Okay, so what is hypothesis? Hypothesis is an assumption about a particular population parameter, and then what we will do? We will going to collect the sample in the form of evidence. We will going to do some statistical test on that, and then we will come to a conclusion that whether our assumption is true or our assumption is false. Now here in this case, the company has claimed that only 5% of their product is defective. Now the company may be producing infinite number of products, or it is very possible to test each and every population unit of the product. Okay, so what we can do, we can select some sample. Based on that, we will see that how many parts of the sample is defective, and based on that, we will going to test our assumption that whether the company is true or the company is false. Now to start with, our assumption will be the company is not saying any false word. Why? Because we don't have evidence, right, to show that they are false. So for the time being, let us consider that the company is true, and if the company is true, then the 80 is called the null hypothesis. So we start the solving of any of these type of problem by setting our null hypothesis. So 80 is what? 80 is the population proportion. See, here they are talking about the entire product that the company is manufacturing. So here the population proportion is nothing but 5%. So I am writing here the null hypothesis. What is null hypothesis? It is the basic hypothesis, right? The assumption that the company is claiming. So here we are writing here that capital P is nothing but the population proportion, and capital P is equal to 0.05. So what is the meaning? The meaning is here that our assumption is that the population parameter, which is the proportion, here is 0.05. What is the proportion? That is the defective proportion of the sample. That is the defective proportion of the product which is being manufactured from here. So H0 P is equal to 0.05. Now there is another hypothesis which is called alternate hypothesis, and that alternate hypothesis has to be mutually exclusive with the null hypothesis. That is, whatever is the null hypothesis we are assuming, our alternate hypothesis must contradict that. Okay, so obviously here H1, what we will write? See, if we are saying contradiction, the most common contradiction will be that P is not equal to 0.05. Now if we write here P is not equals to 0.05, then it will not going to contradict our null hypothesis. Try to understand this. This is very important, and in any hypothesis testing problem, the framing of hypothesis is one of the most significant part of solution. So here if we are writing that P not equal to 0.05, then definitely it is not contradicting P is equal to 0.05. The question is why? Because P not equal to 0.05 may be that P is greater than 0.05 or the P is less than 0.05. So there are two conditions that may be valid in this case. One condition is that here the population proportion may be greater than 5% or the population proportion is less than 5%. So basically what we are doing in simple terms, we will going to test this statement. What is the statement? That P is equal to 0.05. Now while testing the statement, this statement can be true or this statement can be false. So we can accept this null hypothesis or we can reject this null hypothesis. Now if we are rejecting this null hypothesis, then we will be coming over here. That means if P is not equal to 0.05, that means here. Right. Now in this statement, we know that P is either greater than 0.05 or P is less than 0.05. Now the question is, if you are accepting this statement, you are accepting any of these. You are accepting any of these without knowing that which one is true. Now if this is true, say the person is claiming that 5% of its total product is defective, and here we are finding out that P is less than 0.05. That means it is less than 5%. So obviously I will going to say that the company may not be true, but the company is not doing any harm by telling the false or speaking false, isn't it? I am saying that 5% of my total product may be defective and it is coming out less than 5%. So definitely I will not going to say anything to this person, right? But if it is greater than 0.05, then definitely we will going to contradict to what this person is saying, right? So if it is greater than 0.05, then only we can say that this statement is actually getting contradicted. Okay, so that is the reason why instead of writing P not equal to 0.05, here we will going to write P greater than 0.05. So obviously this is the statement. What is this statement? This is the statement which is actually contradicting this. So if this is my null hypothesis, I can consider this as an alternate hypothesis. And please remember one thing, that if we are talking about greater than or less than in the alternate hypothesis part, then we will say that we are doing one-tailed test. Okay, and if this hypothesis is greater than, then I am testing this P is equal to 0.05 against P greater than 0.05. This type of test is called one-tailed test. One-tailed test towards right. Okay, so this type of test is called one-tailed test towards right. So we have to do one-tailed test towards right while testing this hypothesis. Next, in order to test the hypothesis, we can use two types of tests. One is called the parametric test, one is called non-parametric test. Now, in case of parametric test, it is assumed that the sample that we are drawing are coming from normal population or the distribution of the population is defined. But if we don't know about the distribution of the population, then we generally go for the non-parametric test. Also, since the number of sample is 400, so number of sample is very high, so we will going to do the parametric test over here. Also, the proportion is a parameter that we need to estimate. So here basically what we will do, we will going to use the Z test. Okay, we will going to use the Z test. Why Z test? Because n is greater than 30. If n is greater than 30, we generally go for Z test. If n is less than 30, we generally go for T test. So here n is greater than 30, we will go for Z test. Now let us write the formula of Z. So Z is actually defined as observed value minus expected value divided by standard error. Okay, so what is Z? Z is defined as observed value minus expected value divided by standard error. And this sample, this 400 parts which we are taking from and taking it as infinite population because the population is not mentioned over here. So from the infinite population, when I am taking these 400 parts, it is assumed that the population is normally distributed. Okay, this is a very, very important assumption, guys. Please you have to write over here that what is the assumption? The two important assumptions for parametric test. One assumption is the samples are taken randomly from the population and the sample units are independent of each other, number one. And number two, the population is normally distributed. And since it is greater than 400, therefore obviously we can use the Z test over here, and the form is observed value minus expected value by standard error. Now let's understand what is observed value and what is expected value. Now we have taken 400, among which 30 came out to be defective. So what is the proportion of defective in the sample? Okay, what is the proportion of defective in the sample? So you write down small p. Small p stands for the proportion of sample defectives, and the small p is nothing but 30 by 400. So here we are talking only with the proportion part. So this is 30 by 400, which is coming as 0.075. So this is your small p, 0.075. Okay. And what is your capital P? Your capital P is 0.05, which we already assumed in our hypothesis as per the company claim, right? So capital P is 0.05. Okay. So this is basically my observed proportion. This is my observed proportion. Okay. This is my observed proportion. We have taken the sample proportion from here, and this is my expected proportion. This is my expected proportion. Okay, so I have found out the observed proportion, I have found out the expected proportion. Next, we will going to find out the standard error. Okay, now what is the standard error? What is the standard error? So standard error is equal to root over of PQ by N. This is the standard error if we are taking proportion as the population parameter. Okay, then this is the standard error, and if we calculate this will be, this P is the expected P and this Q is the expected Q. What is this P? This is the proportion of failure and this is the proportion of success, and P plus Q is always 1. So we write here 0.05 into 0.95, and here I have taken 400 sample. Okay. Now why I have taken why I have written here 0.95? Because please write, this is important. P plus Q is equal to 1. Okay. P plus Q is equal to 1 because P is the proportion of failure over here and Q is the proportion of success. So proportion of failure means how many defective items, the proportion of defective item. This is expected as 0.05. Therefore, the proportion of non-defective item is 0.95, and this is divided by the number of sample, and the value is coming as 0.0109. If you calculate this will be close to 0.0109. Now what is standard error? Since I am not using all the population units, I am only taking the sample from the population, so therefore definitely I am omitting some error, right? If we would have taken only the population units, then definitely we would have got the absolute value, but here we are not getting the absolute value, right? We are always getting some estimated value, and that's why we have to use the standard error over here. Come to the Z. Okay, what is Z? So as per the definition of Z, right, in the previous part, we have seen that Z is equal to observed value, and observed value is 0.075. This is the observed value, that is a sample proportion, minus 0.05. This is the expected value because we have assumed that this will be the value, right? So this is my expected value, and finally we are getting the standard error over here. What is the standard error? The standard error was 0.0109. So this is my Z, and if you calculate this value will be coming as 2.294. Okay, this value will be coming as 2.294. Now, in the beginning we have told that we have assumed that the population is normally distributed, right? So if it is normally distributed, let us draw the diagram and see what this diagram will look like. And since I am doing the one-tailed test towards right here, see what we are doing. If this is my Z, so we can consider this as the this way. Why? Because this is the value of Z, and this is the sample that we have taken, the population unit, they are all normally distributed. Okay. Now since we are testing one-tailed test towards right, so we will be mainly testing over here. We know that this will represent 0. Okay. This will represent, mean is 0, so Z always represent 0 and 1. So standard deviation is 1. And variance is 1 and the mean is 0. This is the standard normal variate, and the Z distribution follows this. This is a special normal distribution where the mean is 0 and the standard deviation is 1. So now it is given over here Z critical. Z critical means at 5% level. So if this you consider the 5% level, so this is your 1.645. This value is 1.645. This is your critical value. That means this area is 95% level, and this area represents the 5% level. This is the area of acceptance, and this is the area of rejection, and this is a critical value. Critical value means just if you move beyond this value, your result will be rejected. That is, your null hypothesis will be rejected at 5% level. Okay, so for 5% is basically the alpha value, that is the level of significance. Okay, that is it is the highest probability with which, or the maximum probability with which we reject the true null hypothesis. Now our Z value was coming as, remember, it was coming as 2.294, which is much greater than 1.645, and this is a constant value which will be provided to you. Okay, so Z value 2.294, which is somewhere here. This will be your 2.294. Okay, so obviously where it is in the rejection region, right? It is not in the acceptance region. So please remember, guys, if for one-tailed test towards right, if we are getting a value which is less than 1.645, then you will accept your null hypothesis. If you are getting any value which is more than 1.645, you have to reject your null hypothesis. Okay, so what will be the conclusion? Your conclusion will be, in the exam you have to write like this: since Z calculated, what is Z calculated? Whatever Z value you have calculated, and the calculated value was 2.294. Since Z calculated is greater than Z critical, you have to write like this. Okay, since Z calculated is greater than Z critical at 5% level. Okay, Z calculated is greater than Z critical at 5% level. Therefore, we reject 80. Therefore, we reject H0 at 5% level. So, we reject H0 and we can claim that, that the company is, the claim of the company is not tenable. That is, the company person or the company people is not saying the right thing, at least statistically. Okay, so we reject H0 at the 5% level. So, if we summarize it, what is hypothesis testing? Hypothesis testing is first making an assumption about the population parameter and then also constructing a statement which is mutually exclusive to your null hypothesis which you have already assumed. Then you collect the sample evidences and test it with some statistical test, and then we can come to the conclusion by checking the calculated value that you got from your statistical test and the level of significance and the critical value of that particular statistic. Chain is basically a statistic, right? So what we are doing, we are finding out that we are calculating the value of the statistic and then we are comparing it with the critical value of the statistic and that particular alpha, that is at a certain significant level. If it is greater than that, definitely your null hypothesis will be rejected. If it is less than that, your null hypothesis will be accepted. Thank you so much. I hope you have understood. Next day we will be coming up with a new problem. In this problem you already have understood that how we will deal with the population proportion. Next day I will be bringing another problem where we will be dealing with population mean and population variance. Till then, thank you. Goodbye.